Okay, for this week class, this is what we're going to cover. Okay, on module 12.3, solving linear to quadratic systems of equations. So a review essential question you guys should have learned about last year was how can you solve a system of linear equations? We're going to take that, take the skills that you guys learned last year and elevate the question by solving a system of linear and quadratic equations. Okay, so one's going to be linear and one's going to be a quadratic. All right, before we start, what is a quadratic? What shape does it make? Quadratic? A quadratic is a parabola, right? Okay, whenever you have y equals x squared, that makes this shape a parabola, right? And when we graph the line and the parabola itself, remember that the intersections of these two are your solutions. Okay? Just keep that in the back of your mind. But before we get into all that, I gave you this warm up. So let's solve this. Okay? Solve number 1 using algebra, and we're going to solve number 2 using graphing, okay, or by graphing. Okay, so remember that we're going to take this first one. I'm going to use the method of substitution. I'm going to solve for a variable, solve for x, because that's the easiest. So if I add 2y to both sides, then that's going to equal positive 2y minus 6, right? X equals positive 2y minus 6. So now what I'm going to do is I'm going to plug in 2y minus 6 in for x here. So instead of x, I'm going to have 2y minus 6, 4 times x, which is 2y minus 6, plus 6y equals 4. And then I'm going to distribute out the 4 into these parentheses, into the parentheses. So 4 times 2y is 8y minus 24 plus 6y equals 4. Cleaning this side up a little bit, that's 14y minus 24 equals 4. I'm going to add 24 to both sides to get 14y equals 28. Divide by 14 on both sides to get y is equal to 2, right? So I got y is equal to 2. Questions on that? No? So if y is equal to 2, and I know x is equal to 2y minus 6, I'm going to plug in y2 into there. So that's x equals 2 times 2 minus 6. X is equal to 2 times 2 is 4 minus 6. So x is equal to negative 2. Okay? So that's how you would solve a system of linear equations. All right? So x is negative 2, y is 2. So my final answer would be a coordinate, because I have an x and I have a y, of 2 comma 2, or negative 2 comma 2. All right? Questions on that? Okay? That's how you would solve a system of linear equations by substitution. I'm going to solve this via graphing. Okay? So in pink, I am going to graph that one. So an equation in this form, y equals negative x plus 4, reminds me of y equals mx plus b, right? So here, my b value or my y-intercept is 4. My slope is -1. So my b value being 4 or my y-intercept being 4, I know I have to go up 4 units on my y-axis, right? Okay. And then my slope being -1, that means, remember that my slope is rise over run, okay? And that is equal to -1 over 1, right? -1 equals -1 over 1. So if I rise -1, that means I'm going down 1. If I run +1, that means I'm going to the right 1. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And I'm going to get my straight edge because I know that this graph needs to be as accurate as possible, and graph it. Okay. The next line, I'm going to graph that in green. My y-intercept is -8. My slope is 2 over 1. Okay. And I'll let you guys know why I went 2 over 1 for my slope. So my y-intercept is -8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So the reason why I did 2 over 1 for my slope is now I know how much to rise. Now I know how much to run. Right? So I go up 2 over to the right 1, up 2 over to the right 1, up 2 over to the right 1, up 2 over to the right 1. And I'm going to draw my line as accurate as possible, right? Okay, so there's my line, right? Green, pink, and again, I'm going to emphasize this. The intersection of these two lines right here, that point, which is 4, 0, that's my solution. Okay, that's my answer at 4, 0. Okay, wherever, when you're doing it via graphing, wherever the lines cross, right, wherever they intersect, the intersection point is my solution. Okay, so essentially here, when we are solving a quadratic system, right, with a linear line, let's think about it. A parabola with a line, right? Parabola and a line. Or I can go parabola and a line. Or I can go parabola and a line. Right? There's only 3 options that I can draw with a parabola and a line. Right? If there's any other way, please let me know. But a line is straight, right? A parabola is a U shape. It can be an upside down U, right? And we've learned all that in the first semester. What makes it flip upside down? What makes it reflect along the x-axis? If it's negative, right? Yeah, if the whole thing is negative. But here, there's 2 intersection points, correct? So there's 2 solutions. Here, How many intersections are there? There's 0, right? So there's no solution here. Or 0 real solutions. And here, it's just touching it at one point. So if it's just touching it at one point, that means there's one solution, right? I have 0, 1, 2 solutions. What does that remind you of? 0, 1, 2. Starts with a D. The discriminant, right, of the quadratic equation. Yeah, whenever we're dealing with a quadratic or a parabola, right, our solutions are always can be linked to that quadratic formula, right? Remember, a quadratic formula is x equals negative b plus or minus square root of your discriminant b squared minus 4ac all over 2a, right? And this piece right here tells us if it's 0 real solutions, 1 real solution, or 2 real solutions, okay? So we're essentially doing the same thing, right? We're still working with a parabola, but we're just adding a line, all right, in a system involving that. So let's go over some graphing stuff, okay? Solving the quadratic linear system by graphing. We just talked about number 1, right? The intersection of 2 equations are your solutions. During the first semester of this class, we've learned how to graph a quadratic or a parabola, right? Really quick, y equals x squared. X, y, my key points for x was -2, -1, 0, 1, 2. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, right? So your parent function is 0, 0, -1, 1, +1, 1, 2, 1, 2, 3, 4, -2, 4, and 2, 4, right? That was my parent function, correct? And then we did all the transformations in order to graph this or in order to change this picture, right? This graph. If it's a reflection, then it's a negative on the outside. Yeah. If it's a vertical stretch, okay, vertical compress. And when we move it left, right, up, or down. Okay. If you guys do need a review, please go to my YouTube page and watch the transformation video. It should be the first one on the integrated 2, one of the first ones on an integrated math 2 playlist. Okay. But that is my parent function for a quadratic, right? And then we all know how to graph a line, right? And remember, the intersection of the line and the parabola are your solutions. So how many solutions should I have normally? 2 solutions, because in like most problems, you're gonna have 2 solutions, right? Or you can have 0 solutions if they don't intersect at all. We just went over that. Or you can have 1 solution, right? If they just intersect at one point. Okay. So all we're gonna do is just graph these two lines, or these two okay, the line and the quadratic we're gonna graph. So let's graph that line first. I want this in terms of y equals mx plus b, because that's the simplest way. Right, so I'm gonna subtract 2x on both sides to get y is equal, or negative y is equal to negative 2x plus 3. I'm going to divide by negative 1. So we get y is equal to positive 2x minus 3, right? So here, I'm going to start off with negative 3 on my y-axis, because that's my y-intercept. My slope is positive 2 over 1. That means I'm going to go up 2 over to the right 1, up 2 over to the right 1, and so on and so forth. Get my straight edge. And graph that line, right? So there's my line right there, okay? And now if you look at the other one, that is a parabola, right? I am going to subtract 6 on both sides to make it y is equal to 2 times x plus 1 quantity squared minus 6. Yeah? You guys remember the transformations here? This 2 represents a vertical stretch by a factor of 2. The positive 1 that's in here, right? That represents a horizontal shift to the left 1 unit. And the last one, this negative 6, is going to represent a vertical shift down 6 units. Okay, does that make sense? You guys remember that? And again, if you guys don't, please refer to the video. Okay. So I'm going to go point by point. Okay. 0 times 2 because it's vertical stretching. That's still 0. 1 to the left, 6 units down. 1, 2, 3, 4, 5, 6. Right there. That's my new vertex. Negative 1, comma, negative 6. Okay. And my other point was negative 1, 1. If it's a vertical stretch by a factor of 2, it's going to be negative 1, 2, right? And then shift this over 1 unit to the left, down 6. 1, 2, 3, 4, 5, 6. Right there. And I know, class, that my other point here at 1 is just a mirror image, right? So I'm going to mirror the image and put it right there. Does that make sense? Yeah. It's going to be a mirror image along the axis of symmetry, which is cut through my vertex. Okay. So at negative 2, 4, it's going to go vertical stretch by a factor of 2. That means negative 2, 4 becomes negative 2, 8. Going to go across to the left 1 down 6. Right here, right? And since this is 2 units away, go 2 units away, it's going to be right there. Okay? That makes sense, class? And we are going to graph this parabola as accurately as possible, right? So you guys see the 2 points that are intersecting? Yeah? Right there and right there. Those are my answers. Those are my solutions. Okay? But now if you take a step back, right, and look at the graph itself, that's not going to be as accurate as you can be, right? Because you are drawing it. You can put it in the program, Desmos, right, and see what your actual answers are. Yeah, but that's not going to be as accurate as you can if you're drawing it by hand, right? So that is why we're going to learn how to do this via algebra and using the substitution method, okay, and using just algebra in general, okay? So these are the steps of solving a quadratic linear system using algebra. Okay, remember how to use the substitution method? Okay. I use the substitution method because the multiplication method is more complicated. And so I just focus on the substitution method. Okay, and here are the steps that are outlined for you. So let's solve this using algebra. Okay. So your first step is to solve for a variable here in your linear equation. Okay, so I'm going to solve for y. So that's negative 2y equals negative 3x plus 13. Divide everything by negative 2. Divide everything by negative 2. Y is equal to negative 3x plus 13 divided by 2, negative 2. I don't like that negative down here. So what I'm going to do is I'm just going to put it up and change up all the signs in my numerator. Okay? So that's what it's equal to. Okay, and now that I got y is equal to this, I can plug this into my first equation, right? Y is equal to neg 1/4 x minus 3 quantity squared. So instead of y equals, I'm going to go 3x minus 13 divided by 2 equals 1/4 x minus 3 quantity squared. Yeah. And personally, I do not want to deal with any fractions. I just don't like fractions, and they invite like common mistakes, okay, to our process. So I want to get rid of the 2 and I want to get rid of the 4. What am I going to multiply on both sides to get rid of both? No. I want to get rid of the 2 and the 4 because this is also a fraction, right? 1/4 and a denominator of 2. So what's your LCD or your lowest common denominator between 4 and 2? 4. So if I multiply this side by 4, 2 cancels out with the 4, right, and get 2. So I have 2 times 3x minus 13 equals, this 4 cancels out with this 1/4. So I just have x minus 3 quantity squared. Okay? I'm going to go through the steps of solving this equation, okay, to get an x value. Just like how you would in a linear system. Okay, so 2 times 3x, 2 times negative 13. That's 6x minus 26, right? Equals, if you expand this out or multiply this out via foiling, or x minus 3 times x minus 3, or use the special form, which is up here on the board, but that plus would just be a minus. It's going to be a squared minus 2 times a times b plus b squared, right? So that's 6x minus 26 equals x squared minus 6x plus 9. And we solved this last module, right? And we got all the x values here. So my first step is to make one side equal to 0, or minus 6x, huh? And plus 26. So 0 is here, equals x squared minus 12x plus 35. Okay, I'm going to use the steps of factoring. Two numbers that get me a sum of, or a product of 35 gets me a sum of negative 12. That's 7 and 5, but they're both negative. So that becomes x minus 7 times x minus 5 equals 0. So x minus 7 equals 0, or x minus 5 equals 0. So x is equal to 7, or x is equal to 5, correct? Yeah. Questions on that and how I got x is equal to 7 or 5? No? And from here, if x is 7, what is y? I'm going to plug in this 7 into this equation. Okay? So x is equal to 7. That means that it's going to be 3 times 7 minus 13 divided by 2. 21 minus 13 divided by 2. That's 8 divided by 2, which is 4. Right? So I have one coordinate of 7, 4. Yeah? And if x is equal to 5, then that's 3 times 5 minus 13 divided by 2. 15 minus 13 divided by 2. That is 2 divided by 2, which is 1. So y is equal to 1. Right? So my equation, or my coordinate here would be 5, 1. That makes sense? Yeah. That's your lesson for today. And next time we meet, we'll just practice this. Okay? Practice, practice, practice.